Hi everyone. Today we will write a program such that the brightness of the LED will increase slowly. It will reach its peak brightness and then it will decrease slowly. Let's learn how it is done. Suppose I am giving a set of pulses with a fixed time period to my LED. Let the time period be T, and notice over here the time period for which I'm giving these pulses is very narrow. Okay, narrow pulse. If I try to find out the average voltage for this particular waveform, the average voltage will be very small as indicated by this dashed line, low average voltage, if the pulse width is narrow. On the same lines, if I give a set of pulses with a higher pulse width and I try to find out the average voltage, okay, the average voltage now will be higher as shown by this dashed line. Hence, if I control the width of my pulses that is given to the LED, I can control the brightness of the LED. Let's see how it is done. What I will do is I will go to tinkercad. I'll click on circuits, click on create new circuit. Search for Arduino. Place the Arduino over here. Notice that on these digital pins, okay, see this digital PWM, okay, and there is a tilde sign over here. This particular sign is the tilde sign. What it says is pin number 3, 5, 6, 9, 10, 11. They are PWM pins. PWM stands for pulse width modulation. Through these pins, I can give pulses of variable duty cycles. Duty cycle means variable on times. Let's see how we will develop the code. I'll go to code and click on text and then click on continue. First, I will delete the previous code and I will type constant int LED equal to 3. I will use the third pin because the third pin is a PWM pin. I'll go to setup, void setup and say pin mode LED, comma, output. I have declared the pin 3 as an output terminal. Now I'll go to void loop and I will run a for loop. For int I equal to 0, I less than or equal to 255, I plus plus, basically whatever code is written over here, it will run for 255 times. Now I will run the code analog write. Notice that W is in capital. LED, comma, I. What I'm doing here is I have made a for loop where the variable I is incremented from 0 to 255, and at every step the function analogwrite will write the value of I to the terminal LED, that is pin 3. Basically what it will do is it will give PWMs of variable duty cycles. So when I write analogwrite 0, 1, 2, 3, 4, so on, I'll have narrow pulses. And when I will write analogwrite 200 to 255, it will be wider pulses. Next, I will give it a delay of 10 milliseconds. I will make one more for loop and say int I equal to 255, I is greater than or equal to 0, I minus minus analogwrite LED I delay 10. So now in this loop, what will happen is the LED at very high brightness, it will start decrementing. The counter is decrementing and it will write values in a descending order from 255 to 0 to the LED terminal. And hence the brightness of the LED will decrease. The code is over. Let's build the hardware. So I will search for an LED. I will change the color to orange. Connect it to ground. Cathode is connected to ground. Now I will select a resistor, drag and drop, rotate it, place it, set the value to 500 ohms and connect it to pin number 3. Hardware is complete. Let's go to code and say start simulation. Okay, as you can see, the brightness is slowly increasing. It will reach its peak. And now it is decreasing. Again, it has started increasing and now it is decreasing. What I will do is now I'll change the color of the LED so the response can be seen more clearly. So the brightness is increasing and now the brightness will decrease, go to 0. Again it is increasing and again it will come back down to 0. Okay. Basically, pulse width modulation is used for speed control of a DC motor or any other application wherein you require to decrease the average value of the output voltage. Now let us check how this code works in Arduino. I will copy this code, go to Arduino IDE, create a new sketch. I will paste the new code over here, click on File, Save as, Analog Write. Click on Save. Now I will click on Verify Code. The code is getting verified. Then I will say upload code. It has uploaded the code to the Arduino. And now let's check how it looks on the hardware. After the code is uploaded, let's check how the hardware looks like. So I have pin number 3 connected to this resistor. Resistor is connected in series with the anode of the LED. Cathode is connected with the red pin to ground. Let's check how it works. So the brightness increases slowly, reaches its peak, and decreases slowly, comes back to 0. Again, the brightness increases, reaches its peak, decreases, and comes back to 0. Okay. So this is how you can give a variable duty cycle to any kind of load like an LED. You can control the brightness of an LED. You can control the speed of a DC motor. In the homework section, you can write a program such that the brightness of the LED increases slowly, reaches its peak, and then decreases slowly, and then display the level of the brightness at each instant on the serial monitor. Thank you.